The following shaded region correctly defines all the given inequalities. The inequalities x greater than 0, right? So we will have to identify the region x greater than 0 and x greater equal, there's a equal 0, y greater no equal -1, and also x plus y less than equal 0. So we want to identify which one actually is the shaded region. So I'm going to explain to you using decimals. So after you observe, you will see which triangle actually satisfies the three inequalities. So as you can see, x greater equal 0 is always shaded to the right, y greater than -1 is always shaded above y equal -1, and then y less than equal -x, you can shift the x, so it's always below the line. So obviously this is the answer, right? Okay, I'm going to use decimals to explain to you why the shaded region is at the fourth quadrant here. This is a fourth quadrant, right? But you must make sure that the boundary is here, is at the y-axis. Okay, so this is a shaded region, but the this side is a dashed line. Here is a dashed line. Okay, so let's follow my decimals explanation. Have fun! Hello everyone, welcome to my mathematics class. Today, I'm going to question number 2. Which of the following shaded region correctly defines all the given linear inequalities x greater equal 0? So I'm going to show you how I come up with a graph for x greater than equal 0. Okay, let's use a decimals graph to show you so that you can understand the concept. So the first inequality, x greater equal 0, right? So after I key in greater equal 0, x equal to 0 is exactly on the y-axis. Okay, remember y-axis, x equal to 0. X-axis is actually y equal to 0. It's opposite. X-axis, y equal to 0. Y-axis, x equal to 0. You must be very sure. So when x is greater than 0 or equal, it means that it will greater than, it will go to the right. The right number at the right is always greater than. Because it's greater than equal, so it must be a solid line whereby all the border line on the y-axis must be accepted. Okay, it's inclusive. Then I'm going to have y. Okay, I'm going to draw another one, which is y greater than -1. If it is y, it's always a horizontal line. Alright, greater, it will be above the horizontal line. So I'm going to draw y equal to -1 first, but then because it's greater than, there's no equal sign, so it's a dashed line. It is a must dashed line. It's a dashed line. So y greater than -1 is above, alright, above the logically is a logic, because -1 above -1 of course is 0, 1, 2, 3, 4, 5, isn't it? So you always use a logic set. Above means a number that is higher than -1. Alright, so another one, the third one is x plus y. Okay, x plus y is this equation. X plus y less than equal 0. Less than equal 0. This is the line. It's actually y equal to -x. So when you sketch this y equal to, but because of y less than -x, so it will be shaded to the down part. show that the triangle is at the fourth quadrant. So A was wrong, right? A was wrong. And how about B? B, the triangle, it seems like it's at the fourth quadrant, but it's at the boundary of x-axis. Ours one is at the boundary of the y-axis, right? So it looks like B is wrong. And then the C, obviously, is third quadrant is wrong. And then you look at the D, is exactly the same. The triangle that we drawn using decimals with the dotted line, you can see at the -1. Alright, so this is actually the right answer. D is the right answer. Okay, so if I am going to show you the point that satisfies that region, I can read the point. Maybe is the line must be solid line, then it's inclusive. So I can say I can just show you one point, which is 0.5 and -0.5 is exactly at the borderline. That point is satisfied the shaded region, satisfied. Or maybe I can use 0, 0. 0, 0 is accepted because it's at the borderline. 0, 0. Okay, I'm going to draw another point. Let me label the first one first. This one is satisfy the shaded region. Maybe I give you 0 and then 0. Origin is also satisfy the black point, right? Satisfy the shaded region. And if I am going to give you 0, 0 and -0.5, the red point, it also satisfies the shaded region. 0 and -0.5. But if I say 0 and -1, what do you think? 0 and -1, is this point satisfied the shaded region? No, because that line is dashed line. Or 1 and -1 also no, not satisfied of the shaded region. This point in green, blue and green are not satisfied the shaded region. So we just chose the triangle that looks like it's at D, right? That's the answer. Okay, I hope you will understand after I use a decimal to explain to you. So decimals will make you have a clearer picture about the inequalities, right? That's all my sharing. Till then, bye bye and have a nice day.